Hello everyone, I'm Dheeraj. Today we're going to discuss about packets. So what is a packet and how to generally capture it, how to actually see it, what it is made of, right? So let's quickly discuss what is a packet. So packet is nothing but whenever we send information to a like internet. So let's see the previous example which we discussed. If this is just google.com, we generally use to search over the internet. So when we actually do it, so what actually happens, as we have discussed, first it will resolve the DNS query. Once it is resolved, so we will have a proper packet. So what you're gonna do with the www request, so you're gonna eventually be doing HTTPS, because like google.com is generally a secure domain, so we will have a certificate. So we will discuss in detail what are these certificates, but on a brief note, this is just nothing but a encrypted packet. So whenever you want to sniff this packet, so you won't be able to see much information of the application layer, what they are actually trying to search, right? So we won't be having those details because it's a encrypted, and it will be encrypted at the application layer itself. Okay, so what actually happens? So this will be HTTPS header. There will be uh, application header, and then we will be having the same as we have discussed earlier. So this will be, for example, this is the whole information, and here we will have application data, which is like HTTPS. And then on top of that, once it go below to each layer, so it will have all the layers headers. So we will be having a transport layer header. So okay, so let me come to this point later. Transport layer, and then we will be having a IP header. So IPv4 to be specific, if we are using IPv4 traffic, and then we will be having a MAC header, and at last we will be just on top of Mac, we will be having some translation data to convert it into the physical medium which we are using, whether it is Ethernet or Wi-Fi. So those will be information will be here, and there will be a checksum involved at every header. So checksum is nothing but to check if this packet is not like modified in during the way. So there we can check, always check some whether this information is correct or not. So how this is generally calculated: we take the information, we calculate the checksum. So checksum, how it is calculated, so we generally use MD5 sum. So MD5 sum is generally used to collect it. We see if this information is matched with our MD5 sum. So we take the information, we collect MD5 sum, and then match it with the existing MD5 sum, which is there in the packet. So if it is matches, so then we have the correct information. Otherwise, this information has been misinterpreted during the transfer, right? So this is whole at every layer. So we are adding the header. So what this whole information, bunch of information collected together, is called a packet. We call this term a packet, and the packets are generally divided into headers, right? So these are all called as headers. Okay, so this is just about what is packet, and how to capture it. So there are various tools involved, and I'm just going to name it down here, and I'm just gonna give a little bit demonstration about the tool, few tools. So the one is very famous open source tool is called Wireshark. So Wireshark is a GUI enabled. Uh, GUI enabled, when I say, it's a graphical UI, uh, graphical user interface. So graphical user interface means you can it's very user friendly tool, where we can actually click it, actually see the information in a lot more like UI friendly manner, and lot colors are there. So it's very efficient and very humanly readable, better tool. Okay, and it has on top of that, it has a lot of functionalities. There are a lot of things we can do. We can actually check the whole stream of TCP packet or UDP packet. So that is very nice. And then later we have this called TCP dump, and there is very similar tool to TCP dump is Tshark. which is like same as Wireshark and same as TCPdump, but these both tools are not GUI friendly, they are CLI friendly. CLI is command line interface. Okay, so when I say CLI, it means you won't be having any UI attached to it. Okay, UI, it's not user interface. There is no colors or nothing like that. It is just can be run on a terminal, so we can actually see. So it is generally used because always graphical user interface is heavier than these CLI tools, because it has to open UI, and there will be a lot of everything will be calculated, because once you click that button, what's going to happen. So, and it calculates a lot of things on top of that. So on the back end, it will be using some CLI library. So both all these tools, to be precise, they all use one library, which is very commonly called as libpcap. Okay, so this is written in C. Libpcap is a library .so. So is a shared object, which is a which can be dynamically linked to any program. So this is just a program, and we are dynamically linking to all. So all these tools use the same library in a user space. So they use this library to capture the interfaces. Sorry, to capture the packets, add some interfaces, right? So these are the basic tools, and TCPdump and Tshark are basically CLI friendly. So you will have a console, we can say console, when you enter the tool, and you have to run some commands or pass some arguments. I hope you're familiar. If you are from Linux background, you should be familiar with this term. If not, in Windows also, when we use some commands in PowerShell, this is I'm sure like Windows user must have heard about this PowerShell thing. So PowerShell is nothing but a more of admin related stuff we can do, and more controllable than the command prompt in Windows. So when we can use this same TCP dump also, I think I'm pretty sure we can use in PowerShell as well. So we have to pass some arguments, and we can just capture packets, and we can see all the packets there at that time only. Okay, so why to use TCP dump and Tshark? Why not Wireshark? I mean, it's a good question, but let me give you an answer. Wireshark is very heavy tool. One thing, because it requires a lot of RAM to process those graphical interfaces, and process all the things, and show it in a better way. So there are some plugins also involved. So it's always slower than these TCP dump. But nowadays, like PCs have a lot of RAM. Like it doesn't really matter. Like if even if it slows down, it won't be affecting user experience, right? But still it will be lacking little bit capability. But let's not think about that difference. The other difference is basically it requires a basically GUI to show it. GUI means it should have one GUI, like display manager or something, where we can actually show the things. But what if we want to capture packet which like doesn't have any UI? Like for example, some routers or routers generally. Let's take example of router, because in routers we generally have a web page, right? We don't have any UI enabled. We cannot click things. We cannot browse through. Like Explorer or something. By default, we won't be having any GUI or display manager, right? So how to see it? We cannot run this application. It will not run. Basically, it will say like it requires display access, right? To print it into, to show it into the screen. So at that time, these tools comes into handy, and even they are fast. And but the only drawback is they are not user friendly. You have to remember a lot of arguments. You have to see how to process those packets, how to see those packets, and so that is little bit hectic. And the other benefit these tools give is they we can save all the traffic which we are process which we are capturing through these tools in a PKF format, and we can see it in Wireshark. So that's a good thing. Okay, so this is the basic about Wireshark and Tshark, which I wanted to explain. So let's see how to capture it. So how to actually see the packets. So let's jump into this target. Okay, so let me see. This is a CLI of a Linux system. So we can run this command like this. If config is a command to see the interfaces and their information. So let's just run it. So as we can see here, there are a lot of interfaces created. Okay, so because I'm using a lot of things, so there are therefore a lot of virtual interfaces are there. Let's not go into this. So one interface which I have already told you about, this loopback. So here name is LO0. So every machine has a different name. In this loopback interfaces, we have this IP as I told, 127.0. So this is how we can see the information of a interface. So 127.0 is the IP and net mask, and we will see all these details in later videos. But the main thing we have to discuss is like uh, loopback is this, and we all interfaces have a wireless or Ethernet interface where we connect communicate over the network. So here I in this machine we will have this EN0, which is a wireless interface. So the IP is of my wireless interface is 192.168.0.104, which is by default for every. I mean, it's generally used 192.68 for most of the routers for their LAN in net traffic. So this is a LAN interface, and I mean, this is a WAN interface for my machine because our machines can also act as a router, right? We can just create. We have to install some servers, and we can easily provide services to other our clients, right? So for now, this is a LAN IP for our router. Router gave us this IP to communicate to the internet, and this is the broadcast for this IP. Okay, this is not a broadcast address which I told. This is a broadcast for this IP. So we'll see how it is calculated. Our main goal is to see how we can capture traffic, and this is EN0. It's the interface. We have to remember that on which interface we want to capture traffic, right? So this is our EN0. Okay, so this is our tool Wireshark, which I wanted to show you about. So we can easily install it over just Google download Wireshark. So I'm using Mac, so you can find DMZ file for Mac, and if you're using Ubuntu Linux distribution, so you will either find a Debian or RPM package. Right, if you're using Fedora, you have to install through RPM. If you're using Debian system, you can use a .deb file, and if you're using Windows, you will have to install a .exe file. Okay, so this is a wireless interface. As you can see in top of it, also showing the Wi-Fi EN0. So we can just have to click this blue tick, start capturing packets. So it will just start on capturing packets. Okay, so as you can see, we are this is started capturing packet. So on top of this so I just searched google.com and it is starting capturing. And once you are seeing this packet, right, you if you want to read through the packet, if you want to go analyze the packets, then you have to stop the traffic, because on the runtime you won't be able to read because it's a lot of traffic are coming. For my case, I'm not using internet right now that much, so it's not a lot of traffic, but still, as you can see, a lot of packets are coming. Okay, so these are the packets. Generally, this one frame is called as a packet, and as you can see, a lot of information is going on. Okay, I mean, there are a lot of protocols. This is called a protocol chain. We will discuss about this tool as well, how to see it. But for now, we can just simply see what is a complete packet. So this is called a complete, like this is a UDP packets, and these are the data bytes here. We are sending through UDP. Okay, so like that, we are for DNS we have this MDNS protocol. So this is also similar to DNS, but it's multicast domain name system query. Okay, so we'll see all the data. So this is called a header. Okay, let me read a little bit about this. So these are the all the headers. Okay, so this is how we can capture packets. So our goal is to how we can see capture. So this is how we can capture packets. And as you can see in this, we have just queried the google.com, and we will have this address Google cast. Okay, so we are using Google as a searching query. So this is how we can capture the packet. This is the one way. Okay, and the other way is, let me see if I have the binary. So this is TCP dump. Okay, TCP dump we can use. As we have seen earlier, our interface name is EN0, which I'm using currently. And for TCP dump, we can use TCP dump hyphen I to show the interface, to tell the interface on which you want to start capturing packets, and just start it. Okay, you can see a lot of packets are coming. So this is how you can read the packets. Okay, which from which source IP and from which destination IP the packets are going. So this is how this is called a packet, and this is a one packet actually. This is one packet, and we are not seeing the whole headers of packet. There are some command line arguments which we can use to see it. But for now, I'm just trying to tell like this is how we can capture packets. Tshark I have not installed currently, but I have heard about. It is good also. I mostly use TCP dump for CLI and Wireshark for our UI GUI model. Okay. Okay, so I hope you got the idea what is a packet and how we can capture it. So that's all I wanted to talk about in this video. Thank you.